Hello, today we are going to solve this perfect sum problem. We have here given an array of non-negative integers and an integer target, and the task is to count all the subsets of the array. The sum is equal to the given target. Okay, so I was thinking that we can approach this question by using dynamic programming. As the array size is 10 cube and target is also 10 cube, so if n is equal to array dot size, we can go till n square complexity. So over n square is a valid solution. Definitely we can try using this. We can create DP states. Here, here the DP states would store the count of store the uh, count of the number of subsets we get till that. Okay. Okay, now here we can define the BP of I, comma J, J's count of sets up till where, where I elements have been used. I elements have been used, and let me think for the J term. How will define of the J? We have given a target and achieved a target. I think here J is a constant. And J is the target. So when BP of n comma target will be called, we will get count of subsets having target in it. Yes, so now let's see this. This should be initialized like 0. I don't think this is required for you. We can initialize this with we can initialize the um, one because for achieving zero sum structure you just need an empty array. So we can initialize this one. And so now we can write the deepest steps. No, this should be from starting from 1 because we have already initialized the 0 columns. Start with 1. This should J should store all the possible sums. So we should get a target. Here we have two options. Either we can take the subset, take an element of the and add it to the subset, or we cannot. So suppose our first option is if the element of the subset is less than j, so equal to j, then we have two options. We can add it, or we could uh, we can take it and add it, or we should not take it. So in this case, the sum would not change. And the other option is if the element of the subset is greater than j, then we should not take it. Otherwise, this term would become negative, which will cause a problem. We can write it as okay. Mm, now we should. Guys, I think this should be plus because we have to add all the possibilities. Now we could just return it. But I should. Yes, I think that's done almost. Yes, now we could return the return we took when we checked all the possible subsets Then how much target, how many, let's check if it's working nice. Shootings. Yes, yes, it's submitted. It's submitted. What is the mistake? Let me check once again. What mistake did I do here? This is perfect. This is also good. This is also good. Hmm. Should be less than zero. Okay. What is the mistake over here? Let me diagram it. First, we took the size of the nums array. Then we wrote the DP. We initialized the DP with the with n rows and the sums from 0 to target. Then we initialized it with, suppose we took 0 elements. Then for forming the sum, we need 0 elements, not 1. Okay, so here it is the mistake. Here I think it should be 1. Now let's try it. I'm getting still a mistake. Let me once try. Mm, we need a table here. Let's go to the table and see to drive. Here we have 0. Here we have the sum as 0 and the number of armed elements as 0. This would always be 0. But suppose when we have one element over here, then for getting the sum 0 as a count can be 2. We are for getting some, either we take 0 elements. Uh, no, it should be I think 1. This is wrong, guys. Here it should be 1. And then we have, because there is a count of 1, we need, here if we check here, then it can be 0, 1, 2, So now I explained you that why should this be because if we did not if we have zero subsets and we have to get a zero sum, then there is only one way. Then suppose we have a zero subsets and we have five subsets and we have to get zero sum. Then it will be a zero way. So I think now it should work. What is the problem? Okay, I think we should be starting from zero. Because you already initialized one again. Yes, it works. Left side. Yes, it's successful. I hope you have understood this question, right? Thank you.